Greetings learners, and welcome to another awesome edition by ICampSA. In this edition, we are going to be looking at practice problems, and these are specifically on geometric series. All the problems we'll be looking at are sourced from past papers. So we'll do November questions and then do June or May questions. So there's about 10 of them which are compiled in total. So let's have a look at the first one. So the first problem is from the 2024 November exam, and this was question 3. So the statement reads, a circle with radius 6 is drawn, a second smaller circle is drawn through the center of the first circle and also touches the first circle internally, and this process carries on and on. So question 3.1 requires us to write down the radius of the third circle. But in order for us to have an appreciation of what is going on here, I'm going to quickly draw these circles and then we label them. So I'm going to draw the second one. Then let's draw the smallest one. Okay, then I'm going to move it inside like that. So that is what we have. So let's make it a bit smaller. And let's see if we can make this one a bit bigger. Okay. Right. So what happens is we have the center here and we also have the center there, and I'll make the center of the smaller one to be somewhere there. So there's a couple of things that we need to do. So the radius of the bigger circle from there, essentially from here to there, that radius we are told that it is 6 centimeters. Okay, but what we can clearly see is that when we look at here, this is also supposed to be 6 centimeters. This is not drawn according to scale, but we can see that it's only halfway. So this means that the radius of the next circle just becomes 3 centimeters. Okay, but if you observe carefully the third circle, this was also supposed to be 3 to make the 6, but we are only going halfway as we did with the other one. So even this one is halfway. So this means its radius is half the other one, which is just going to be 3 over 2. So this is just going to be 3 over 2 centimeters. So if you think carefully, the pattern will carry on and on and on. So now they are looking for the radius for the third circle. So for 3.1, which is the third circle, we can give them the radius. So the radius is simply 3 over 2 centimeters, which if you want, you can write as 1.5 centimeters. And then next, let's have a look at 3.2. So we are required to find the sum of the areas of the first 10 circles. So this is very interesting. So what we can do is let's quickly note down the radiuses. So we will start with a 6, a 3, and then a 3 over 2, and so on. Okay, so with these radiuses, what we can do is we can always find the area of these circles. So remember that the area of a circle is always given by pi r squared. That is how you get the area. So what we can do is we can formulate a sequence that is made up of area, because for this one, what we are looking at is radius. So I'm going to calculate the area using the pi or using 6. So that is going to be 36 pi. If I square that, and then I go to the next one, that just becomes 9 pi when I calculate the area. And then for the next one, when we square that, it just becomes 9 over 4 pi. And this carries on. What this is here is area. So I'm making a pattern using our area from these, what you would call it, radiuses above, because the question clearly wants us to find the sum of the areas. So now looking at the areas, I need to figure out, is there a pattern? That is the next thing. So looking at the areas, we can clearly see that the area, or A, which is the first term, that will be 36 pi. And then if we look at R, let's see if R is going to work. So we'll have 9 pi over 36 pi. That will be. So that just becomes 1 over 4, okay, when you calculate your R. And then we can just confirm by using the next term, which is just 9 pi over 4. And then divided by 9 pi. If you observe carefully, you'll get 1 over 4. So we now have our R. So we can now go and do the magic. So this will just become the sum of 8 terms. So remember, Sn for a geometric series, which is what we are working with, is just a into 1 minus r to the power of n divided by 1 minus r. So in our case, we're looking at the sum of 10. The sum of the areas of 10 circles. So this will give us the first term, which is 36 pi. Maybe let me just take it just below here. So we'll have our A, which is 36 pi, 1 minus our R, which is 1 over 4, all to the power of 10. And all of this will be divided by 1 minus R. So let's go and calculate the sum of the areas of 10 circles. So the answer which we end up getting is 150.796. And remember the units, we are looking at centimeters. So this is going to be centimeters squared. So next, let's have a look at 3.3. And 3.3 is asking us which circle has the diameter of as given there. So let's just paste this on the next page and start, looking into this question. So what you should notice, we are looking at diameter. And guess what? For our problem, what we were working with here was radius. So I'm sure you can guess what I'm going to do is I know that how you move from radius to diameter is just you multiply it by 2. So your diameter is 2 times your radius. So I'm going to formulate a new series, which is just going to be 2 times so that it speaks to the diameter. So I'm going to have 12, and then I'm going to have 6, then I'm going to have 3, and so on. And guess what? The series here speaks to the diameter of the circles. So I can clearly see that A will be my first term, which is 12, and R will just be 6 over 12, which will be 1 over 2. So I can now write my general term, Tn. Remember, Tn is A times R to the power of n minus 1, which means I will have 12 multiplied by 1 over 2 to the power of n minus 1. And guess what? I have the diameter already, Tn, which is 3 over 128. I just need to figure out which circle is this. Okay, so let's go ahead and solve for n. So we have 12 times 1 over 2 n minus 1, and this is equal to 3 divided by 128. So what I'm going to do is to divide by 12. So let's copy this. So we are going to divide by 12, such that all what we have now is just 1 over 2 n minus 1 equals. So the answer which you end up getting is 1 over 512. Okay. And then there's something which you can go and do on your calculator, where you can express this 512 as a base of 2. And 512 as a base of 2, it is 2 to the power of 9. So what you do on your calculator is you press 512 equal sign, and then you say shift fact for factorizing. It will allow you to get that. But what we know is that when you have a 1 on the numerator, the power can actually be put outside. So we can have 1 over 2 to the power of 9. And guess what? Once the bases are the same, all what we do is we just equate the exponents. The bases are the same. What needs to be equated, it is these guys, the exponents. So n minus 1 should be equal to 9. And if you look carefully, you will see that n will be 10. So what is our conclusion for this problem? It is the 10th circle which has a diameter which is equal to that. So that is our conclusion. So our conclusion is that it is the 10th circle that has diameter 3/128. Centimeters. So I hope this does make sense and you actually understand the problem which we just did now. So the next problem will be a problem from the 2022 exam paper. Let's have a look at it.